Well, now we're going to talk about how we can use area of different types of shapes to figure out a little bit more of a story problem. They're not really that difficult, though. This one I actually borrowed straight from Khan Academy because that's what I'm going to give you for assignment, and I just wanted you to see a couple of the ones that we need to handle here. So, for example, what is the area of the shaded region? A circle with a radius of 2 sits inside a circle with a radius of 4. So this white circle has a radius of 2 right here. But the bigger circle that the little circle is sitting in has a radius of 4 here. So we've got all the information that we need, but here's what they want. What's the area of the shaded region? So what it comes down to is this. If we were to look at a circle the size of the big one, if we pulled this circle off to the side, that's the same size as that big blue one, okay? Well, what's happening is we could absolutely find the area of the big circle. And we could do the same with this little white circle right here that's got a radius of 2. But they don't want the area of the big circle, and they don't want the area of the little circle. They want just the shaded blue region through here. So if we could literally just figure out the area of the big circle and then subtract, like with scissors, cut out that little white circle and subtract that area from it, we would know what the area of the shaded region is. So the very first thing we need to do is we need to find the area of the large circle. So A equals pi r squared. The radius of the big one is 4, so it's times 4 to the second power. So that's going to equal 50.24. And most of this you can do on your calculator, so I'm just going to erase this and make a little note. Area of the large circle is 50.24. Okay. Area of the small circle, same thing. A equals pi r squared. This time we're going to be using radius of 2. And we would type in 3.14 for the pi times the radius, which is 2. That r is going to become a 2, and then we need to square it. And it's going to equal 12.56. So let me erase all of this and just kind of slide that up there. Now, we've got the area of the large circle, we've got the area of the small circle. Really, all that we need to do is we just need to subtract. It's kind of like cutting out the small circle. And there we have it. The area of that shaded blue circle is 37.68 units squared. Since they didn't give us the exact type of units, we'll just use the generic units squared. One last problem right here. We want to find out the shaded blue area right here, and it's going to be the exact same thing. Let me go ahead and clear this off right here. The square is a 3 by 3, so the area is found by using base times height, and that literally just means 3 times 3. So that's our area for the square. Okay. But for the circle, we're back to using pi r squared. So A equals 3.14 times 1 to the second power, and hey, you put it in a calculator, amazingly, it's 3.14. Okay. So what do? We take the square area and we subtract the circle area, and we get 5.86 units squared. So with these, hey, find the area that's shaded with like an internal shape inside. Just find the area of both shapes and then just subtract them, and it works every time for this type of problem.